In this video, we are going to learn how to convert decimal number to the binary number. So what is a decimal number? Well, a number that can be represented with the base 10 and number which is represented with base 2 is known as the binary number. So let's just say that we have a number 85 and we have to convert it into the binary number. Well, to do that, first we have to be familiar with the powers of 2. So that is 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, 2 to the sixth power is 64, and 2 to the eighth power is 128. So these are the powers of 2's. And why did we stop at 128? Because 85 is less than 128 and more than 64. So that is why we have to stop at 128. And the method we are going to use over here is the subtraction method. There is also another method to do this problem, that is the successive division method, which we are going to look at later in this video. Alright, so to do this, first we have to look for the highest number that is below 85. So that number is 64, which is right here. So we're gonna subtract the 64 from here. So we would have 21. Now we're gonna look for a number that is below, highest number that is below 21. That number is 16. So we're gonna subtract 16 from 21. So we would have number 5. Now we're gonna repeat the process to look for highest number below 5, that is 4. So we would have 5 minus 4, that's going to be 1, and the highest number below or equals to 1 is the 1 itself. So we would have 1 minus 1 equals to 0. So now we're gonna place the number 1 over here because we have the 64, 0 because there is no 32 that we have subtracted it from, and we have 16, we do not have 8, we have 4, we do not have 2, but we do have 1. So 85 in binary would be written as 1 0 1 0 1 0 1. So this is going to be the binary representation of the number 85. Now let's look at another example. So let's say we have to convert another number, say 132, into binary number. So again we have to write the 2 to the powers. So 2 to the power 0 is 1, 2 to the power 1 is 2. Okay, so 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the second power is 4, third power is 8, fourth power is 16, fifth power is 32, sixth power is 64, seventh power is 128. Now the number is more than 128, so so we have written till 7th power, so 2 to the 8th power is going to be 256. So we know that the number is highest number below 132 is 128. So we're going to subtract 132 by 128. So we would have number 4, and the highest number below 4 is 4 itself. So we would have 4 minus 4 equals to 0. Although this is the shortest example, but you can do many more. So now to represent 132 in binary, we're going to look for the number that has been subtracted from. So we had 128, we did not have 64, 32, 16 or 8, but we did have 4, we did not have 2 or 1. So In binary, it's going to be represented as 1 0 0 0 0 1 0 0. So that is how it's going to be represented in binary. Alright, so this was the method of subtraction. Now we're going to look for the method of successive division. Here we are going to use this previous example, that was to convert the number 85 into a binary number. So to do that, we're going to divide the number 85 by 2. So we would have 42.5, that is 42, with remainder 1. Now we're gonna divide the number 42 by 2, so we would have 21 with remainder 0. Now we're gonna divide the number 21 by 2, so we would have 10.5, that is 10, with remainder 1. Now we're gonna divide the number 10 by 2, so we would have number 5 with remainder 0. And we're gonna divide the number 5 again by 2, so we would have 2.5, that is 2, with remainder 1. Now we're going to divide the number 2 by 2, so we would have 1 with remainder 0. And we're going to divide the number 1 by 2, so we would have 0.5, that is 0, with remainder 1. Now stop over here and look at this remainder series. In here, this one would be the MSB, the most significant bit, and this one is the LSB, the least significant bit. And the way to read it is to go from the MSB to the LSB. So we're gonna write it over here, that is the 1 0 1 0 1 0 1. So that is going to be the answer. And if we were to look at this is the same answer that we have calculated by using a subtraction method. So this proves that the validity of this method. Now we're going to use the same method onto the another example, that is to convert 132. So we would be taking the example of 132 to convert it into decimal number, to convert the decimal number of 132 into the binary number. So we're gonna divide 132 by 2, so we would have here 66 with remainder 0. Now we're gonna divide the number 66 by 2, so we would have 33 with remainder 0. Now we're gonna divide the number 33 by 2, so we would have 16.5, so 16 with remainder 1. Now we're gonna divide the number 16 by 2, so we would have 8 remainder 0. 8 divided by 2 would have 4 with remainder 0. 4 divided by 2, we would have 2 with remainder 0. And 2 divided by 2 would be 1 with remainder 0. And 1 divided by 2 would be 0 with remainder 1. So we would have the MSB in here and the LSB here. So we would go from the MSB to the LSB. So we're gonna write the result as 1 0 0 0 0 1 0 0. So that is going to be the answer. If you were to check it from here, so we have the same answer. So that's all for the day. Thank you.